Chapter 5. Chapter 5 is our last kind of probability distribution, and this one is about the normal distribution. So you've had binomial, Poisson, and geometric. This one is called normal, and it's when you're studying things that follow something called the normal curve. You might have seen something like this, where the middle of this curve would represent the mean or the average. And so if this was, like if you're graphing frequency, for instance, the further away you are below average, see how down here there's not as many people that have that score or that height or whatever it is you're talking about. And the further you get above average, the less and less people that have that. So that's a different kind of distribution we're working with. We're not using our calculator functions for this. We're going to use something called the standard normal table. I'm going to upload a copy of it to Blackboard. There's also a copy of it in your book. But that's where we're going to get our probability answers from. From binomial, Poisson, and geometric, you got your probabilities from using your calculator function. So you had all those formulas in there. We're going to use a table for this so you have a different means of getting your information. But before we can start that, we have to backtrack and get this one important skill, and that's for calculating something called a z-score. So a z-score tells you how many standard deviations a person is. Standard deviations. I'm going to put there are. Now remember, a standard deviation tells you how far away from average are most people. How far away from average. And a z-score is telling you how many standard deviations you are. So if you think about it like this, in the United States, in the American, I don't know what it's called, but the regular old standard IQ test, the mean score, remember this is our symbol for population mean, the mean score on an IQ test is 100. So if you have an IQ of 100, you are right smack dab average. And the standard deviation, for this example, we're just going to assume, what if the standard deviation was 5 points? Remember, standard deviation tells you how far away from the average most people are. So if my standard deviation is 5 points, that's like saying most people are within 5 points of that mean. Well, a z-score tells you how many of those standard deviations somebody is. So if I have person A and they have an IQ of, let's say, 115, and you have to calculate their z-score. I'm not even going to give you the formula. I want you to just for a second think about it. A z-score is how many of these that person is. So if the average is 100, and a standard deviation is 5, the z-score for somebody that has an IQ of 115, the z-score would be 3. Because you are 3 of these 5-point chunks above average. 3 standard deviations above average. So that would be a z-score. And we always put z-scores, by the way, in hundreds, just like if you think money's always in hundreds. Z-score, same thing. So 3.00, that would be that person's z-score. All right, so let's look at person B. If that person had an IQ of 90, and you had to calculate what their z-score was, remember, z-score is how many standard deviations there are. Average is 100. They're 90, so they're 10 points below average. That would mean a z-score of not just, we don't say 2, because you are 2 of these standard deviations, that's correct. But since you're below average, you want to say -2. So an IQ of 90 would be a z-score of -2 because you are 2 standard deviations, 2 5-point chunks away from average. So it's logical, you can do it in your head, but there is a formula for it. And what you just did every time, whether you knew it or not, is to find a z-score. You took the actual score, So we're going to call that the x value, the actual score, whether it was 90 or 115, and you subtracted the mean. So you figured out basically how far away from average were there, and then you divided by the standard deviation. So that's our symbol for population, standard deviation. And that's your formula for z-score. This you will use over and over and over again. You need to memorize it. You need to know what the symbols are because you're going to use it frequently. The nice thing about z-score is it basically allows me to compare different people. So if I work in admissions and I have a Virginia student that took the SAT and a Tennessee student that took the ACT, I can't compare their scores and tell which is a better student because the SAT is out of 1,800. Is it? No, out of 2,400. And the ACT is out of, I don't even know, 36 or something. But if you calculate both students, the z-score for the SAT using this formula, and then the ACT z-score, if they're both in terms of a z-score, now I can compare the two students. So that's why it's important. You need to know that formula. That's one of our skills for Chapter 5. And the other reason it's important to know that formula is because our chart, in order to use our chart that gives us our probabilities, you have to look it up by z-score. Okay, so that's why our skill number 1 is calculating z-score. Skill number 2, let's look at reading the chart. So basically what's going to happen before I pull up the chart, this would be, if I mark z-scores on the bottom, a z-score of 0 means you are 0 standard deviations away. That means you're smack dab average. And so a z-score of 1 would be about here. A z-score of 2 is right about where it starts to level off, and a z-score of 3 is out here where it gets low. So that would be positive. And then you have the same thing, only like negative would be below average. -2, -3. Okay? And the questions are going to be things like, what's the probability of somebody's z-score being lower than, for instance, -0.5? So I want this right here. It's actually an area. And if you want to know, which I know you don't, but if you wanted to know where those chart numbers come from, they come from calculus. You're doing the area under the curve. But if I want to know the probability of somebody's z-score being less than something else, then that's what the chart is going to tell you. It's going to tell you, it's going to give you a number, which basically gives you the area to the left of a certain z-score. So here's how it looks on the chart. Look at this crazy thing. So the chart. Some things I want to point out to you about the chart. First of all, you see that Z right there. That means that's how you're going to tell which of all these crazy numbers you're going to choose. Well, you're going to look it up by z-score. The other thing you need to know about the chart, well, there's lots of things, but one of them is there is a negative side of the chart. See how all the negatives are right here? And there's also, oh, I think it put the positive one on another slide. So there's 2 pages to this. One page is where you have all negative z-scores, where you're talking about people below average. And then the positive z-scores would be people above average. But if you recall, what we were working on is what was the probability of somebody's z-score being less than like -0.5. And I told you that we always do z-scores in hundredths, just like dollars and cents. Here's how you find the answer to that. Oh, poo, hold on. Well, first things first. So you're going to look up your z-score in 2 sections. The first thing is you're going to look it up by the ones and the tenths digit. That tells you where in this column to go. So I want to go to the -0.5 row. That's right there. All right. And then I need to look at this number separately. So I want to be in the 0 column. So if you notice, let me scroll up. So this is the, oops, this is the 0 column. That's the 1 column, 2 column, 3 column. So this is what, when you look for what's the number in the hundredths place, that tells you what column to go to. So you look for your ones and your tenths place, that tells you what row. Your hundredths decimal tells you what column. And I have the number negative 0.50. I want to be in the 0 column, which you can pull it back down if you need to see it, but I'll write them under here. That's the 0 column. That's the 1, 2, 3, 4, 5, 8, 9. And they write it like this, 001, 01, 02, 03, because that's where it is. It's in the hundreds place. So, if I want to know the probability of somebody's z-score being less than negative 0.50, okay, again, I go to the negative 0.5 row, and I go to the 0 column. That number right there, that's my answer. The answer is 0.30854. That's the probability. That's just like your answers to all your binomial, Poisson, and geometric problems. Looks the same way. This is my probability that somebody's going to have a z-score less than negative 0.50. And it says at the top, it reminds you in case you forgot, the chart will only tell you the probability or the area of being less than or to the left of a particular z-score. All right, let's do another one so you have practice. Let's pull up the right chart. Not right chart. Not right chart, but greater than chart. So, let's just do this all right here so that we don't have to shrink it, okay? So let's say I want to know what's the probability of somebody's z-score being less than 1.78. All right, so less than or left, that's what my chart tells me. So all I've got to do is look at the z-score 1.78, and then I'm going to find my answer. So you break it into two parts. Go to the 1.7 row, that's right here. Go to the 8 column, that's right here where it says 08. And where those two meet, all right, so here's the 1.7 row. And then I'm going to come down the 0.8 column, and where they meet, that's your answer. That's the probability. The answer is 0.96246. That means there's a 96% chance that if you randomly select somebody, that their z-score for whatever you're talking about is less than 1.78. Or, you know how when you got your scores back, it gave you a percentile? Like you're in the 95th percentile or the 17th percentile. That's where they got that, from this right here. So that person would be in the 96th percentile. All right, so let's cut this video and then keep doing more problems.